Many people want to do data science beyond just for fun or as a hobby, but they want to produce work professionally, but they don't have a good set of principles to follow. So a lot of times you say that, well, Sam, I know a little bit of Python, I know how to write R code, I know a little bit of SQL, I know how these pieces interact with each other, but somehow when I see AI software, when I see machine learning software, when I see a web application doing this stuff, I don't know how they come together. I don't know how these pieces actually come together. I do know a Python code, I do know R code, but I don't know the bigger picture. I don't know what other things have to, what other components are there in a machine learning project. That's the first kind of use cases. There's also a second kind of use cases where folks look at what they do right now and they say, how do I actually take this and package it and reproduce and make this build a business out of it? Get this from, how you go to like online tutorials and you follow something and you feel very satisfied after that because you see that it runs in your notebook, but then you don't know, okay, where do I go from there? Because surely enough, I cannot take this notebook and give it to my client and ask them to pay me money. Like I know how to write all of this in Google Colab, but can I actually write all of this in Google Colab and then say, hey, look, I've done it in Google Colab, now I need to charge you? You can't, because the company doesn't care for that. The company needs you to solve a problem. The company is paying you money so that you can solve its problem. And you say, look, I know how to solve the problem. I can prove to you that I've done that. And the reason I can prove to you is because I have this somewhere on the Google Colab or on my Jupyter notebook. But think about it for a second. You think the company cares for that? It doesn't care for that. The company needs you to solve a problem and you're not doing it, right? So how do you go from these different steps? And this kind of disconnect actually exists for I know this firsthand because we work a lot with companies. I do a lot of on the hiring side as well. I hire a lot of people. I do interviews almost on a weekly basis to try and bring people into a company because I run 2 companies now. And so I kind of witness it firsthand, right? About folks who are, they invest a lot of money into their education. They maybe go to a good school, graduated, maybe ITB, maybe BNUS, right? Maybe UGM, whatever it is. When they graduated, they have a pretty solid base but they felt like there is such a big disconnect between that and people who are doing all these things that are fun in the front. So I thought, maybe why don't we start there? Why don't we start from defining a little bit about what are we trying to solve, or how do we maybe take a step back and how do we define what is professional even? Okay, I mentioned earlier that chances are you can write a lot of code, but think about the last 200 lines of code that you write. It doesn't matter what it is, R code, Python code, Jupyter code, doesn't matter. Think about the last 200 lines of code that you write. There is a good chance that those code doesn't make it anywhere to production, or that code doesn't get you paid at all. So you're doing it for fun. As long as you don't get paid, you're doing it for fun. Okay, if you're following some tutorials on Medium and stuff, that's good. That's all fantastic because you like to learn new stuff. That's all incredibly good, right? But you're not getting paid. Okay, you're not doing it professionally. So chances are, if you think about the last 2,000 lines of code, they sit somewhere on your GitHub as well, and again, you're not getting paid, right? So when you think about it, when data scientists learn and acquire all these skills, they learn how to do, they learn how to write code. So you see that at the left, you see the writing code, and then hopefully that code gets turned into something. And that's something we could generally categorize them into 2 sections. The first one is it could turn into some sort of data analysis, right? Where you learn how to prop data, drill data, like a surgeon, you drill the data, try to find some useful insights. And that's the first kind of data science work. Not a bad idea. It's pretty good because a lot of companies sit on a lot of data and they don't know what to do with it, right? So not a bad idea. Then there's the second category where you say, oh, I write some code, and hopefully some of that code make it into a product feature, make it into a software. Okay, make it a useful product. Now, how do I define product? I define that as any kind of software where you have more than one audience, and that audience is not yourself. So if you build something, if you build a package, an R package, for example, and you have more than one user, and you are not the only user of that package, then you have a product. That's how I define it. Okay, so again, there may be a bit of like differences in how you define product, but how I define it is that if you launch, let's say, a Python toolkit, a R package, a Shiny app, and you're not the only person using that Shiny app, then you have a product. Okay, then you have a way to actually commercialize it, market it, put a price tag on it, and trial it, and get people to start to pay it. Because that's incredibly incredible passive revenue generation right there. If you can build a product that people want to use, and you can start off very low. You can say, yeah, you know, I'm just going to charge you, I don't know, $6 per month. Very affordable, $6 per month to continue to use my Shiny dashboard. What my Shiny dashboard allows you to do is to go to download your CSV file, create some analytics, create some charts, and then allow you to send it to your boss. Simple service. Anyone who has gone through the academy know how to do that. Anyone who have gone through at least the Algorithm Full Stack Academy, who have gone through at least the DB course, you know how to do that. What I just told you there, launch a Shiny app, get people to upload CSV, drag on something, and then enter an email and say, oh, I want to send it to my boss every single Thursday or something, and you get it. Then that's something you can put together in less than maybe a weekend, right? There's something you can put together, and you put a price tag on it. Let's say $6 per month. Okay, so a fair price, very, very cheap price. People look at it and like $6. That's nothing. That's 60,000 rupiah. That's nothing. I'll pay for it. Okay. The moment you have more than one sign-up user, the moment you have more than one person signing up to your software, use it, then you have a product. Then you have a way to actually make this real. Then you can actually do this for real, and you don't have to, maybe work a day in your life anymore. Just scale up the product and make sure that more customers. But if you think about this whole process, going from writing code, writing in Jupyter, and then packaging up into software. So this is 4 steps, okay? First step, write code. Second step, make sure it at least run locally in your notebook experiment. Third step, packaging it. Fourth step, software. The first big disconnect that you need to have, the first mental model, the first lesson of the day, is that a lot of times you refactor heavily, meaning what? Meaning a lot of times you write your code in your notebook and you realize that none of this is actually usable in the end product. Why is that? A couple of reasons. But for example, I list down here 1, 2, 3, 4, 5, 6 different examples. But let's talk about the first one first, right? Procedural code or modular code, functional or object oriented. Now, the first thing about writing code in notebook is that very, very commonly, you open up a Jupyter notebook. Actually, this is a good time to actually just go through that. I'm going to use RStudio because it's faster and it's, I don't have to open up the terminal and stuff. Or I can actually just use it from here. Actually, I don't even need RStudio. If I don't want it. Okay. But since this is open already, we might as well use this one. So I'm going to open up R Markdown. My experiment, right? Just going to put Samuel. Click OK. Clean out all of this stuff. Okay. So I have an empty notebook. Now, you realize that a lot of times when you write notebooks, when you write stuff in notebooks, when you write code, how to open, bro? Like you can go and download. It's up to you. If you want to code in Python, you can go and download Python. Just do a download Python Google search. Do a Google search on this. If you want to use R, you can just do a Google search on download R. Yes, it's both free. It's all free. Yeah, it's free. So R and Python are both open source and free. Yeah. So do a Google on that, like download Python, or you can type download Python Mac or download Python Windows, and you can do that. This is not the main topic of that, but I want to show you how it looks like when people are writing code, right? And let me save this somewhere on my desktop. And I'm gonna just call it experiment. It's not really important what it's called. I just want to show you how it looks like when I write things, and then I'm going to show you how I do that when I'm doing product development. Okay, and I'm going to ask you to find the differences a little bit. It's very subtle, but you're going to see that a lot of times if you're not aware of the different mental models, you go into a lot of these kind of conflicts where you write code and it should work, but then your company doesn't like it. It's like it doesn't work. This is not how we want to write code. Okay, so let me show you that. Now I'm in my desktop right now. Okay, and I'm gonna find some data. I don't have much data, so I can find the retail, I guess. I think this is the one, and I'm probably gonna just take the retail data, go into my desktop and drop it there. Okay, and I'm gonna just read the CSV in here. Okay, so I'm gonna just call retail, and I'm gonna say read.csv, and I'm gonna just read the retail in that. There's nothing fancy in here. And then I'm going to print out the first few rows of the data. So what I just did was I said, okay, take the data that I got, put them, it's on my desktop. So I say read it from my desktop and then show me the first 6 rows of the data. So this is what it does. And a lot of my Kickstart in the past uses Python, so sometimes they switch it up, it's good. But later you see me hopping into Python again. So no worries about that. Okay, this is not the main idea. But do you just see what I just did here? The first thing I want you to notice is, what did I do? I created a global variable and name it retail. That's the first thing that I did. Then use head and call it procedurally. So what does it mean by procedurally? So meaning I would maybe take this data and I would say, okay, take the retail, take the ship date and convert that, take the ship date as well and convert that. And how do I convert that? I give it a format. And how do I do the format? I look at this. And so what do I have here? I have the month, the date, and the year. So I know that this is the month, this is the date, because the month cannot be 18, right? So I'm going to put the month slash the month, the date. Why is it slash? Because here I see a slash, okay? And then space slash year. And then I said, okay, this is what I'm doing. So let me comment all my code here. I'm going to say, you know, I'm a good citizen. I'm a good data scientist citizen. So what I'm going to do is I'm going to comment my code. I'm going to say, read the CSV from our disk or from our drive, and then perform some data cleansing. In fact, not just one, but multiple. So let me go ahead, copy that as well, change that as well. Now instead of ship date, I'm also going to change the order date. Order date as well. And then what am I going to do next? I'm going to change the ship mode to a factor. So I'm going to say retail, ship mode, change that to a factor, right? So what am I doing when I show you all of this stuff? I'm trying to show you one thing. The one thing I'm trying to show you is that I'm doing all of this procedurally, meaning I'm going through a procedure. I'm going through a procedure of first step, second step, third step. In fact, I could break it down and say, first step, perform a date conversion. And then finally, let's do the second one. Perform another date conversion. And then finally, we say change to factor, meaning categorical. In pandas, in NumPy, we probably say something like categorical. Okay. Finally, we print out the last thing, which is print the last 6 rows of data. Okay. How do I do that? I put a tail, put a retail, and run the whole thing. Okay, now it's executed, but now I see that this is a date format, this is a date format, this is good. Remember, if before I do all of these procedures, look at this. If I skip all of these procedures, right? If I skip all of these procedures, right? And I run it, you will notice that these are all characters. You notice that? This is a character. These are all characters. But when I run through my procedures, so let me run that, save it back in here. Now there are dates. So what I do is I read some data in there, I clean up my data, and then I print that out. But this pattern here, you will almost never see in any kind of serious business, in any kind of serious software engineering team, in any kind of serious IT team. Why is that? Because it violates a few principles. The first thing is you're creating global variable everywhere, which means you're gonna pollute the namespace. Imagine you upload your code, you put them somewhere. Somebody also created that, you know, write a similar copy of that, and they also call it retail. So now what's going to happen is that there are 2 variables named retail and you don't know which one to use. So when you work in a software engineering practice, when you work in a software engineering team, you will almost never have to create any global variable. If you're doing that, you're probably doing it wrong. Almost everything is locally scoped. Everything is within a nice object-oriented manner. And everything is properly locally scoped. Nothing should be created in a floating variable like that. Okay, this is just a floating variable because later on you'll be reading something and then you call another retail or something and it will still exist, right? So this is not very sound software engineering practices. So now what you need to do is that before this can be made into any kind of production, you need to change all of this stuff. You need to create a function for that. So you probably do something like function, you say clean. Yes, sure, I'll share that to you, no problem. And then you say share clean, and then what you do is that you say, okay, here, or maybe you say clean, and you say share, and then this you say input data, right? And then you do your actions in here. So this is the first step. So you can say input, or maybe you can say path to data, right? So the first step is what? The first step is you basically said, oh, I want to first take the data from the path. So what you're going to do is you're going to say read.csv, and you're going to say path, and you're going to name it to an object. Whatever object, you can name it whatever you want. But you realize that now X is going to be locally scoped. So this is very different from the one above here. Let me put that in here. So here, X is locally scoped. Meaning you can have 20 people on your team, all of them, let's say you work in a company like Tokopedia. You're not going to be the only developer, man. You're not going to be the only person in Tokopedia doing code, man. There are going to be a ton of people writing code. A lot of people are going to name it X. A lot of them. Okay? So if you name it X, now it doesn't matter anymore because this is all local, meaning X doesn't exist anywhere outside of that. So I can call clean and I can put in my data in here like that. I can do it like that. And if I print X, it says it doesn't exist, which is good because it should never be polluting your namespace. This is never polluting it, right? So then you write your processes in here. Then you continue your processes. You say perform a date conversion. But then you realize, oh, I'm repeating all of this stuff. So what do? Well, I'm going to create another helper function. So you then go in there and you create another helper function. You may do another function, then do something else, and then you perform the function. Okay. So there's a ton of things that you do that are very different from when you first learn how to write code. But almost exclusively, if you go to YouTube, I promise you this, if you go to YouTube or you go to Coursera or go to Udacity, go to Udemy, go to any kind of online learning facilities, right? And you go and try and learn code, right? Almost exclusively, people will teach you how to write code like that first. Because this is easy to reason about from a beginner point of view. Okay, I first created this stuff, it happens there. Now I do something and I put that. Even if you've never written code before, you can see this and you can understand what I'm doing. Compared to, oh, this is a function and the function do this and do that. It's harder to reason about, right? So this one, people love doing that. And people use Jupyter Notebook, they use Google Colab, they use RStudio, but this is easy to reason about. Like, okay, first step doing this, read the CSV, and then second step do this, third step, it's procedure, it's step by step. It's based on these certain processes, okay? And then I is smaller than some sort of like customer. Let's say you work on a customer project, and then you say I++. Have you seen code like that? And then you say, take the customer, I, and then do something to it. So let's say we say do something. I don't know if you've seen code like that, but if you have seen code like that, right, you would think that, okay, I shouldn't exist here. You can print I here. So what this will do is that it goes through I start from 0, it goes in there, it iterates that, and every time it iterates, it adds 1, and you print I. But the crazy thing here is that at some point in your code, you do something else. You do a lot of other things, and then you print I again. You know what's the crazy thing about this? I still exists. It shouldn't exist. It should be scoped in here. It should be scoped in here, but it doesn't. It's now anyone can call I. I still exists here. So when you print I, you get a result. Like 9 or something, which is ridiculous, right? Or maybe you define I up here. But when you print I, it returns 9. Why? Because this is not globally scoped. There are programming patterns that allow you to do crazy things like that. And you're like, yo, bro, but I just defined I to be 5. How did I just print I and it gets 9? Well, because this stuff here, right? So when you put everything globally, this is okay if you're doing some sort of experiment, code experiment. This is all okay. But it's not so okay when you're trying to build real projects for real people with real customers. Not so okay anymore. So these are things that you need to be aware of. And I feel like people are not talking about it enough. Everywhere you go on the internet, you find content tutorial about, oh, do this stuff, or define it here, declare it here. Nobody teach you how to create real object-oriented stuff, real function, real thinking about real software and thinking about real practices. No one just define this here, declare this here. You don't do that at all, right? So this is the kind of a mental disconnect, and I want to talk about that first. Like, this is so early on in the slide, only page number 5, and look at what we look at what we're hitting already at page number 5. All right. Let me stop a bit. You just installed Python. I hope you can share the recording. Yeah, sure. I won't be able to share the entire 4 hours recording because we're going to chop it out in pieces, but I'm going to share the highlights and stuff. But this whole thing though, if you want to, I will send it to you. Yeah, no problem. I can send it to you. Okay. But yeah, and thank you for helping me out with participating in this when I ask you like constant let or constant variable. If you know the answer, put the answer in the comment so I know how many of you resonate with the message. If you don't know what JavaScript is, don't worry. It's not about that. But if you know that, you know how horrible that is, right? And some of you said not anymore. We don't do that anymore because it's bad practice, right? This is the same. When you do R code, when you learn R, when you learn Python, it's so easy to fall into the temptation to think that, oh, when I can do all of this in my notebook, then I can already launch my product. I don't have to learn anything. But then you realize that, oh, crap, it's almost like I've been doing it wrong the whole time. And we're only at the first 2 points. There are so many other things that I want to talk about. Okay, how we start to think about data science software first. You need to know what your software is going to do. You need to know what you're going to solve, what kind of problems you're going to solve. Are you trying to replace, try augment? Okay, let's take a look at this, right? When we talk about augmenting, when we try to build software to augment human capabilities, we call them assistive, right? They're not trying to replace human. They're just trying to assist human, okay? They're augmenting human capabilities. They're allowing human to make the final decision, but they're trying to assist in the decision making. I'll give you some very clear example of that. So the augment human capabilities, for example, there are a lot of tech right now that focuses on the legislation, the legal side of things. For example, how do you get people to, you upload a nice PDF contract, it scans through the whole PDF contract, and they give you summary of the contract. But the human decision still needs to make decision on that. Still needs to say, okay, look at that stuff. How do I, you know, what do I need to focus on? Do I need to make a call? Do I need to agree to that term sheet? Agree to the investment? Don't agree to the investment. So humans still have to make a decision, but the human software come into place by highlighting everything so that the human doesn't need to sit there for 10 hours reading through 50 pages of contract. He just needs to look at the summary. There are a lot of software who does that, okay? Including a lot of Gmail services, email services, they try to do that. I don't know if you use any kind of like Gmail plugin or Gmail extension that allow you to like, you add this extension to Gmail, it will provide you this service and that service. A lot of times, what it does is that it doesn't try to automate your email. It doesn't try to say, oh, from now on, you don't have to send any email. You still send emails, but it helps you make better, let's say, grammar. It helps you make better grammatical structures. RPA is another example of that, but RPA doesn't really try to do augment, right? It tries to do something else. So it's probably in the replace human capabilities. So that's the augment human capabilities area. There is a second group of software that focuses on replacing. They try to make computational decision. Notice that the big difference from the one on the left is that the software that falls in the category on the right, they try to take the decision making out of the human. They said human doesn't want to make the decision. The human shouldn't be making the decision on that stuff. The algorithm should be making the decision on this stuff, right? Like what? Now, credit scoring used to be very augment human capabilities. Credit scoring used to be a human decision making process. I think till today there are still banks who largely follow that practice. Now I think there are some participants. Let me. Okay. So. Yeah, I hear that too. let me mute. Okay. Is it muted? Okay. So there are software that used to be more towards the left. So for example, like we talk about the credit scoring model. When you build a credit scoring model, back in the past, up to modern day, there are still a lot of places where credit scoring is still a human decision-making process. But the software comes in there to provide analytics on that. It's like, okay, this is the tree, you should look at that stuff, you should look at this stuff. This is the score. But given the score, what should a human do? That's up to the human. And then replace human capability. Replace human capability. As more and more we move towards the right, you see that now the human decision making is starting to get abstracted even. So now you're seeing that the human, the replacement, what it tries to do is that it says humans shouldn't even be making the call on this stuff. The algorithm should be making the call because the algorithm is actually more accurate and the algorithm can provide a more true objective measure that actually optimizes towards a certain objective. And that objective could be, in machine learning, we call it the cost function, right? The cost function or the J data. We like to call it things like that. But really what it tries to do is that maybe we can build a neural network that solves that problem for us, like automation, right? For example, another example is the self-driving car technologies that you see today, the autonomous vehicle. The autonomous vehicle itself, that is actually fully replacing human capabilities, right? So when we talk about them, you look at the difference. The first one on the left, there is the keeping people in the loop. It's to try and engage people, and the purpose of that software exists to help replace cognition with perception. And the one on the right, let me use my pen. Sorry, let me bring up my pen here. So the existential purpose is to replace cognition with perception. So humans have to make the decision, but humans used to have to think about them in, it takes a lot of mental capacity. So what it does is that it says, no, what if we just use perception? What if we just replace that? And try to replace that with perception. Now, what is one example of that? One example of that is data visualization. Is data visualization. And this is so true in many, many different areas. This is so true in many, many different. I think this is especially true when it comes to like COVID. Let me actually see if I can share some of these materials, because I think this is important that you understand that. Because if you don't understand, like, oh, what's the difference? What's the data science software and stuff? Then 29,000 responses. Imagine we don't have the tool called visualization. Imagine humankind or data scientists haven't invented a tool called data visualization. Imagine we live in a world where data visualization as a field doesn't exist yet. Nobody knows what data visualization means. So back then, what do we do with these 29,000 responses? What do? We see them in a plain old CSV format, in a simple table format. Okay, I'm asking you to imagine that data science software doesn't exist. Data visualization as a tool doesn't exist. We haven't really imagined such a thing yet, okay? So what do we do when we try to understand this? We're looking at 29,000 responses and what? And we're trying to sift through all of this stuff, trying to make sense of the data. This is very heavily cognitive, highly cognitive. Takes a huge amount of mental workload, right? So this is obviously a horrible way to make decision. Not just for the senator, not just for the policymakers, not just for Indonesian policymakers. This is a horrible decision making. This is a horrible method of making decision, because with all of this data, you cannot actually find a way to meaningfully sift through all of that and say how much of that can we distill that to real insight, to real actionable insight. You can't. Now, look at what happened with data visualization. Now I'm going to use a different color. What happened is that instead of asking you to do the mental load like that, what it does is that it takes this and it uses a different representation. Representation, okay? And what does it do with this representation? It says find all this vaccine, take all of this vaccine, find how many of them that have symptoms, take them and visualize them as well. Take all of this and visualize all of this, and also in fact even back this is the vaccine to filter the dashboard by, and show me all of this by states. So all the states of America, right? So you see Florida at the bottom here, then you see Arkansas and all that up there, you see Washington up there, you see all of these different visualization like that. Now the human only need to perceive it that way. Now if this doesn't make sense to you, try to imagine an Indonesian map. Okay, I just randomly search it out. So try imagine Indonesian map. Now your cognitive burden goes down a lot. Previously, in order to make sense through all the data, you require a lot of cognitive burden. Now you require almost even a child. Okay, no hyperbole. Even a child can look at this and tell you where is really serious, what is really happening. A child may not be able to go through that orange path. A human expert may be able to do that. But then a kid could now look at this and tell you, okay, it seems like this county or this state is not, and this and that, can make decisions now, can form decisions. So what did we just go through? Let me clear all my screen, clear this one. So what did we just go through? We go through this process of augmenting human capabilities, and the way we do that is that we actually try to find a representation. Oops, did I miss out some slides here? Okay, here, right here. So what did I just do in the entire last 5 minutes is I just replaced cognition. I offload that cognition task to perception. Perception is your eyes. Important because it makes you valuable on a team. People respect you because you know that stuff, So I'll show you that later when, for example, this is how a web development project looks like. This is very simplified. This is how it probably looks like in real. Now, a data scientist knows how to do a couple of things. For example, a data scientist can be expected to know how to do visualization logic, cleansing logic, and filtering logic. So, but the data scientist probably doesn't know any of this stuff. Or maybe knows machine learning logic as well, but doesn't know any of this stuff. Doesn't know how to do authentication. So, when I build a software, everyone on the internet can see it. And then you say, no, I don't want that because our data is so sensitive. You as a data scientist should guard our data. So create an authentication system. You say, I don't know how to do that. right? So I feel like even if you don't want to learn that to be, even if you don't want to be a web developer or to develop your own web development service to launch your machine learning model, I feel like knowing that stuff, just learning that and getting an understanding of that, which is something we will cover, will help you be respected in your team, because your team can respect you because you can have empathy. You know that all these different things have to be done, so you do this very differently. So it changes how the way you code, it changes the way you deploy your code, it changes the way you hand off your work, because you understand what it looks like to make a project for real. And you don't just want to like, oh, here's my notebook, good luck. You know, everything else is up to you guys. You know, my job is done. I'm a data scientist. I don't want to handle cookies. I don't want to handle anything like that. You guys go ahead and decide that, right? So it helps you get respected. I think if you know how different components work, you just naturally become, you just naturally have a level of empathy about how to write your code, how to modularize your code, how to package your code nicely, so that anyone else, let's say you work on a Traveloka team, anyone else on a Traveloka team not responsible for data science can take your work and make use of it, and like, okay, thank you Yvonne for writing it this way, because it makes my job so much easier, because I'm handling this area. So I feel like data scientists should, if you don't want to learn the whole thing, at least get an understanding, which is something that I'm going to go in cover in depth later. I want to talk to you what happened when we hired data scientists who doesn't know any of this stuff. So just now Yvonne was asking, what if we hired somebody who doesn't know how the web works, but he's a really, really good data scientist, so really, really qualified, but we hire this person, and this person doesn't, let's say we're trying to launch something on a mobile app, but this person doesn't know how a mobile app operates or how a web browser operates. What happened? This is a real life story. I told you that I used to work in the industry for a pretty long time, and we had problems like that before. We hired somebody. I can't replicate that because that was back in 2013. So what I decided to do was I launched a new thing, and I sort of play around with that to change the parameters and stuff to recreate the situation so that I can show you and allow you to play with it. So allow me to bring up my web browser right now, and let me find that. Okay, let me I think it's in my code sandbox. So I want you to help me with this. I want you to help me identify where the problem is. Okay, now, so let me briefly describe what my software does, and then we can take a look at what it really is. Okay, let me turn on my software first. npm run dev watch, launching. Okay, go back down, open run server, done. Okay, done. So what it does is that it basically allows you to create assessment. So you can go in there and create an assessment, and you can say this is a live demo for, what is it called? What is a kickstart for fun to profit? And then you can create you can make it public. You can add description, a simple assessment for students. Workshop. Create the workshop, create that stuff. Now it's created, and then I can go into my edit mode, and I'm gonna add a few dimensions. I'm gonna add data visualization. So for example, I'm gonna ask you a question, data, and you see that it created that in real time. Create another one, and I'm gonna say machine learning this time. And I'm gonna create another one, and I'm gonna call it domain expertise, because that's pretty important. I mean, you can have all the DB and ML skill in the world. If you don't have domain expertise, you're probably not gonna do very far. And then we're probably gonna say some like work experience, because that's also one of the requirements, right? Now notice that when I do this, right, I'm creating this nice dimension chart here, this radar chart here. Now what am I doing is that I'm allowing people to go into my, let me go back to my studio. So I'm not gonna go and spend all this time doing this stuff, because I already created one for you. And if I go into one, so for example, are you somewhat familiar? You can tick this checkbox, but what my software would do is that it would give you a sandbox so that you can see how you compare in all these different areas. So for example, how many hours do you practice? Maybe 5 hours per week. Industrial experience, maybe this. Are you yes? What medium have you tried to learn programming? Online courses, YouTube, bootcamp, maybe school, maybe take away YouTube. Actually, yeah, maybe that would be fine. No. Okay, done. So while you do that, you will then see how you compare or how you map, and then you see, oh, I'm really weak at industry knowledge, for example, right? Going through an assessment. Now, well, in the process of creating this stuff, I wrote the code, but this is a lot of code to show you, and it would be very overwhelming. So what I did was, before the workshop, I opened up a Sandbox and I recreated that, but with lesser code, so much smaller. Okay. So now I want you to look at this code here, and I want to show you one thing. Is that this code works fine, and I can change that. I can say, well, what if I change this score to, let's say, 5, and here I change this to 7 or 1, right? You see that as I change this stuff, and maybe software and maybe 2, or maybe you see that as I change this, I get a different kind of graph depending on how I change this figure. But there is a problem. There is a problem. And the problem is that if any one of this score is 0, my app crashes. My entire app crashes. And this happened in production over and over again. So here I'm recreating this situation. So I obviously already know how to fix that. But this is a real situation that I was running into. But the data scientist was like, no, this doesn't make sense, because I experimented with this in my Jupyter notebook. It works perfectly fine. It's a simple set of map, and look, if I change anything else, this doesn't respond anymore. Why? Because the whole app just crashed. Even if I change it back to 3, it just wouldn't work anymore. Even if I reload the page, now it goes back to 3, it will work again. But notice, okay, let me show you again, if you don't believe. Let me change another thing here. Software skills, right? I'm going to change that to 4. Okay, change that to 3, still works. Change that to 2, still works. But if I change that to 0, my app crashes. But the problem here is that now I'm telling you this as if we already know the issue. Back then the problem was, we did not know that was going to happen. We did not know that the model that was was handed off to us, was not robust enough that we launched it in production, and this thing happened. This thing actually happened. So what happened was, they brought me in as a consultant, sit down with them. Obviously everyone is very defensive, right? The data scientist is very defensive, because she feel like very accused, like, why are you saying it's my fault? It's not my fault, because I proved to you that it works in my notebook. It works. It works all the time. Why is it that when you pop my code into the browser, why is it that it's crashing your app? I don't know. And this is crashing real hard. Like, it doesn't even matter what you change now. You change it back to 1, it doesn't matter anymore, because the whole app just failed to respond. This also happened in real life. If I change it back, my whole app will crash. My entire app will crash. So it doesn't even matter what the user is doing, the whole app will crash. So why is that? So can you maybe, I'll give you a hint, if I may give you a hint. If you look at all of this, can you get a sense of like where could be the problem? Like, let's say you are the consultant that they pay money for, not me. They pay you good money. They say, come in here, okay, and help us solve this issue, because we don't know what to do. Our users are complaining. They can't log into the app because our app keeps crashing, and they don't know what's happening. But all they know is that your app keeps crashing. But the problem is, you talk to this person. You talk to the person that was uploading this code. She said that everything works. The code was copied line by line. Not a single thing has changed. The development environment is very close to the production environment. Same programming language, same dependencies. Everything is source controlled. Why did it keep crashing the app? So, anyone have any kind of guesses? You have any guesses? Like, why that could be? You have any kind of like, I suspect it's this, I suspect it's that? Open browser console, let's do that. Nothing really that shows anything that was wrong. I look at everything here and nothing, there was no deviation or anything like that as well. But the logic is the same. But look, there is nothing here that shows that anything was wrong. Everything was fine. In fact, there was only a warning, wasn't even an error. Same dependencies, same version, yes, Ahmad got the correct idea. The math.log, right? The math.log is the prompt. What is the log of 0? What is the log of 0? Negative infinity, right? Let me show you that. Let me open up my okay, let me open up R. This is R. I'm back in R. Okay, I'm back in R. This is my R. Log of 0. What do I get? Negative infinity. So I sort of prove it to you. I know that already, but the client doesn't know, right? The client would, why would the client knows anything like that? I hire a data scientist. Why would I need to know that log of 0? Why would I need to know that log of 0 is negative infinity? I'm the CEO of the game company. I don't need to know this stuff. I hired the data scientist. She's supposed to know that stuff, right? So let me exit R. Don't need that now. No, cancel that. Exit that now. So the console is not giving you any hint. Some of you are very smart, like, oh, just open up the console first, take a look at that. They also did that. Don't you think they would do that? Like, I mean, the app is keep on crashing. So they wouldn't have paid you money before if they can really figure it out. They couldn't figure it out because the browser wasn't saying anything wrong and it just wasn't doing anything. So the problem here is actually in this area, is that you log the score. So how would you fix this? Now that you know the problem, how would you fix this? This is good. Because this is some real life experience that you probably wouldn't get from coding bootcamps. You probably wouldn't get from like coding schools. People were gonna tell you that this all thing works because you're working with clean data that doesn't have any kind of edge cases, you know. So this wouldn't be an issue if you read from CSV data, right? Add a condition statement. Input should be -0. So this is a very good start. Risky, that's a really, really good start. So what I would do is you can probably go in there and say math.min or math.max, and you can probably do this and say 0, right? So when you do a 0, then you put a 0 in here. The maximum it can go is that it goes up here, because the 0, it guarantees this result here, because if this is -infinity and 0, which is the larger number, 0 is the larger number, right? So you don't need to do any kind of if else. You don't need to do any kind of default number. You don't need to do any kind of conditional. You don't have to do anything. You just have to max it. So that will solve the issue. Okay, so these are the kind of things that you need to be aware of, because if you don't understand, if you don't have empathy, and you put out code like that, and this is just a small issue, I can tell you there are a lot of things, a lot of problems. Every time we work with, every time I hired data scientists to work on production projects, these are the kind of things that would happen. It happened very often, and no one is there to blame, because what is wrong? I mean, this person is using exactly the same code. Everything should work. It doesn't. Now the thing is that why it doesn't crash your app is that -infinity was a very valid value in many programming languages and in many environments. For example, if you were to do exactly just now what I showed you here, and you try and do that in RStudio, you will not crash RStudio, because RStudio accept that as a valid value. If you're not trying to compute that to no ends, if you're not do that. But in the browser, now the browser is not RStudio. Remember that. When you do your code experiment in RStudio, for example, your browser, this is a very real browser. People have to, this is a real browser that accepts HTML, CSS, and JavaScript code. Now that, so when people get to see this is rendering in a different environment from the data scientist environment, which is in the RStudio environment. And so this is a very, very small example of that. I can give you a lot more example, but I thought that the point is already made. The point is really clear, like, that I already made my point. I don't want to keep on going about that, but I thought I'll mention about that. So it's very, you need to, if you want to be liked in your workplace, you want to be loved in your workplace, you want to be a data scientist and be loved by your workplace, you need to understand the environment that you're working in. You need to think about those kind of edge cases. So a data scientist who have some knowledge about how the web browser works, how the JavaScript behave, how does this and that behave, would already have a much better advantage over the other one who is a really, really good data scientist but have no understanding of that. Okay, and that is why I thought this workshop was important, because I wanted to bring up all of this example, and I have so many other examples that I can bring up, but I thought that this is an important workshop because I want you to be at least aware of that. I'm not saying you need to go and learn JavaScript right away. I'm not saying that. I'm just saying that you need to have an awareness of when you operate in the real world.